A tangent line is a line that touches the graph of a function in exactly one point.
The slope of a tangent line can be found using the limit as h approaches 0 is f of x plus h minus f of x over h.
In this example, you find the slope of the tangent line to f of x at x equals 2 for the equation f of x equals x squared. You start with the formula for finding the slope of the tangent line. Next, you plug f of x equals x squared into the formula in place of f of x. Since you're finding the slope of the tangent line at x equals 2, plug 2 into the equation for x. First, solve for the parentheses, then simplify so you can cancel the 4's. Next, you can factor out an h from the numerator and then simplify by canceling the h's in the numerator and denominator. Since you're solving the limit as h approaches 0, substitute 0 for h.
A derivative is the slope of a tangent line.
The slope of the tangent line is 4 because the limit as h approaches 0 is 4. That means that the derivative is also 4 because the derivative is the slope of a tangent line.
For this example, find the equation of the tangent line to f of x at x equals 2 using the slope that we found in the previous example. Plug in 2 for x to find the value of y. We are given that x equals 2, and after solving for y, we found that the point where the tangent line touches the function is 2, 4. Use slope-intercept form and plug in 4 for y, 4 for the slope, m, and 2 for x to solve for b. After solving for b, you find that the value of b is negative 4. Plug in the new values, 4 for the slope, m, and negative 4 for b to complete the equation of the tangent line.
This is an example of how to calculate area under the curve. You start out with the graph of a curve and then you find the area underneath and between the axis. You use rectangles to approximate the area under the curve. So to draw them, you draw a dotted line from in between 2 points on the graph, and where it touches the curve, that's the top of your rectangle, and you draw rectangles like that. Now to use the rectangles, you find the area of each individual rectangle, and then you add all those areas together to find the total area under the curve. So over here, the area of one rectangle is length times width. So you find the area of each individual rectangle, and you can plug it in and add them all together to find the area under the curve. So the area under the curve is approximately 20 units squared.